FCC, third nearest neighbor, the last part. Wait a second. Okay, I have to correct one thing. What we did here was, if you can remember, we were calculating the distance from this half of the edge length to this half of the face center, okay, and I mistakenly took this length as a root 2 by 2, okay, which is not correct, because this length is not a root 2 by 2, because this is not going to come. If you draw this line furthermore, it will not come as the face center. It will be passing through the wall. If you look in your wall and try to mark a atom in the middle of a wall and then move a line
sir.
from the
It will be in the center of the edge. Yeah.
Right, it will be in the center of the edge, not a root 2 by 2. So we have to take and we have to consider a different triangle rather. Okay, we will consider a different triangle. Okay. So the triangle that we will be considering is the triangle, this line here and this line here. Okay, so I have come from the black to the purple kind of corner, and then from here to here I am moving in a wall, and then I have this length here. So this distance, we want to calculate this distance. So this is a, and now this is a root 2, right, by 2. This is now a root 2 by 2. Correct? Yes or no? This is a root 2 by 2. Now it is a root 2 by 2. So the distance will be equal to a square plus a root 2 by 2 whole square should be equal to a square plus 2a square by 4, and this will be equal to 4a square plus 2a square by 4, which will be equal to 6a square by 4, which will be equal to 3 by 2a. If I, wait a second, not 3 by, yeah, this will be 3 by 2a square, correct? This will be 3 by 2a square.
Yes.
So d will be equal to the root of 3 by 2 a square. So from here, a will come from the root, and you will get root 3 by root 2. Now I will ask you guys to remember it as a root 3 by root 2, because if you say a root 3 by 2, you can say a root 3 by 2, right? But this and a root 3 by 2. So when you speak both of these things, they sound similar. This is a root 3 by 2. This is also a root 3 by 2. Yes or no?
Yes, sir.
And they sound similar. Now here you can say a whole root 3 by 2, but whole you may not remember. So I would ask you guys to remember it as a root 3 by root 2, a root 3 by root 2. Okay. And I don't know why I wrote here 8. It would be 6. Okay. A root 3 by root 2, and this number, it will be 6, because a is what? Corner's length, right? So corner's length will be, we will have only 6 number of atoms in corner's length. If I took this atom, so 1 atom here, 2 atom here, 3 atom here, 4th atom will be here, 5th atom will be here, and 6th atom will be above. So the number will be 6 here. Okay. So this is the correction that I needed to make. Is that right, all of you? Yes or no? Fine. Okay.
Yes.
We have also done the chart, right? We have also done the chart. So start with now the formula of compound. Okay. So 23 April. Achha, so did you guys come to know about that this chapter is being deleted? Huh?
Sir, ye kab ho gaya?
Okay. Yesterday only.
Yes, yesterday.
Yesterday happened. Okay, but don't worry. Like, this is the one of the reason that I teach this chapter. Sabse pehle, because once also it had happened, I think somewhere in 2016-17. Now I teach this because it is going to come in the entrance examination, है ना? लेकिन अब, like, the enthusiasm or the attentiveness with which the students study this chapter, like in ignorance कि आ रहा या नहीं आ रहा पता नहीं ना, तो सब पढ़ना ही पड़ेगा. So in ignorance it is nice, but now since CBSE has announced that it is not going to come in the CBSE board exam, they're like, अरे एक chapter छोड़ देंगे, NEET में कितने marks का आ जाएगा, JEE में कितना marks आ जाएगा, एक chapter छोड़ देंगे, नहीं पढ़ेंगे. So don't be like that. In this chapter you can see this completely logical chapter, जिसमें आपको you can remember the sequence of each and everything, and it is easier to score this in NEET and JEE also. Okay, so the questions, let us start with questions. Okay, let us start with questions. So wait a second, rather. Achha, what are you guys preparing for? Both of you have maths or?
So PCMB.
PCMB, but like you're more oriented towards NEET or JEE? NEET. What about Hamza?
None of the above.
None of the above. But still, you will be giving some examination, right?
Yes, inshallah.
So which examination will you be giving, like NEET or JEE?
No, I'm not planning on giving NEET or JEE.
Then what are you going to take?
I don't know, sir. But not NEET or JEE.
Okay, but not NEET or JEE. Then you're from India only, right?
Yes.
You're going to prepare for NDA or something?
No, I'm not going
No.
to go in India.
So you're not going to be studying in India. Okay, fine.
Yes, inshallah.
Achha. So where are you planning for, and what subject are you planning for?
Not sure yet.
Okay, you need some guidance, it seems like, huh? You
Yeah.
want to okay, fine, then we can talk about it someday. Okay,
Yeah, inshallah.
inshallah. Sure. Okay, fine. So okay, so here we have a question. Now if you remember the chart that we have shown now, that chart is very important and many questions can be solved from that chart. Okay, so all of the things are present in that chart. So please write this question. Lithium crystallizes in a body-centered cubic crystal, BCC. The length of a side of the unit cell, that is the edge length, is 351 picometer. The atomic radius of the lithium will be. This came way earlier. Now at that time there was no NEET. It was All India Pre-Medical Test, AIPMT 2009. Okay, so this came in AIPMT 2009. It's funny if you solve questions that you have already solved in my. I remember this question from my 12th standard only.
So do we have to use the AR relation?
Yeah, exactly correct. AR
Okay.
relationship between A and R.
So it's option number 2.
Yeah, correct. Option number 2. Okay, so what's the relationship? It is A root 3 is equal to 4R, correct? And they have given
Yes.
you the atomic radius of lithium. It will be how much? Okay, they have given you the unit cell. You have to find the radius. So R will be equal to what? Root 3 by 4 A, correct?
Yeah.
I know. You have found this
Yes.
only, yeah? Okay. So root 3 by 4. Root 3 is how much? 1 point?
1.73 something.
1.7. Okay, divided by 4 into A is how much? Yes, 351 meters. Okay, so as you can see, 1.7 divided by 4. How can you approximate this? Tell me.
It came 151.98 something. So I did 151.18.
Correct. So see, as you can see here, the difference between the values are very large, right? Yes or no? 250, 151, 75, 300. So what you can do, you can approximate this to 2 by 4 also. And you will see that it will be somewhere near how much? 351. What will be the half of 351? 100. How much? 75, right?
Yes, sir.
Approximately. So what is the nearest to 175?
151.
Or next thing what you can do, what is nearest but not higher than 175? Right? Because you have taken already this as height, 1.7, you have already done it high. So what you have to look at a lower value that is nearest to 175. Okay, got it?
Okay,
Even
sir.
if you had one option, let us say 180, then 180 is never going to be the right answer, even if it is nearer to the 175, because we have taken 1.7 as 2, and so we are approximating at the highest level. So the answer cannot be higher than 175; it will be lower only. Okay, so you can do this type of approximation to save time. Okay, next is if A length is the side of cube, the distance between the body centered atom and one corner atom in the cube will be how much? Okay, so please do this. So we have a corner atom, and then we have the body center atom here. What will be the distance between these two? So this is from the nearest neighbor of BCC, because these two atoms are the nearest neighbors.
Sir, is it option number 4? Second nearest or first nearest? First nearest.
First nearest neighbor, no? Body center
Yeah,
atom and corner atom, the first nearest neighbor. Okay. So we have 3 atoms like this, and these all are touching each other, right? And this is the body diagonal, which is A root 3. This is R, 2R, and R. So A root 3 is equal to 4R. But if you look at this distance, this is what? A root 3 by 2. This distance, yes or no? The distance between corner and this is the body center, right? So this will be A root 3 by 2. This is the answer, fourth one. Okay. Now let's look at one more. The number of octahedral and tetrahedral and octahedral weight in HCP, hexagonal perimeter unit cell. Okay. In hexagonal unit cell, what is the number of tetrahedral and octahedral weights? Now this question is recent only. This came in 2021.
So 6 and 12. Option number 4. Sorry. It will be 12 and 6. 12 and 6, yeah.
Mistake. Okay. So this was recent only, like in past year also only this came. What will be the number of tetrahedral and octahedral weights? Okay. So now let us move on to, so you will be getting this type of questions in which you have to calculate the relationship between the edge length and the radius, also sometimes about the tetrahedral and octahedral weights. Okay. Now there is a different type of question that is about the formula of compound. Okay. Now this type of questions are more important. Formula of compound or solid. Okay. So let us start with type 1. In type 1 question, what you will be given? You will be given the exact position of, the atoms that are present. So let us say you have been given a question such that a solid is formed by two elements, P and Q. Please write this question with me. P and Q. Atoms of P are present in the corner of Q, and atoms of Q are present at face center. Okay, derive the formula of solid. Okay, now please look at this question and just see how I am doing this. It is going to be very easy. I'm just giving you the procedure and whatever insight is there. So I'm giving you the recipe. The ingredients are with you, but I am giving you the recipe. Okay, so see, solid is formed by two elements, P and Q. Atoms of P are present. Now you will see P present in the corner of Q. Corner of Q. So first thing what you will do, you'll write P like this, and then you'll say it is at the corner of Q. And then you will tell me how many corners are there in a cube. How many corners are 8 corners, and the contribution of each is
1 by 8.
1 by 8, and this will give you 1. You will circle it, and then you will write Q. And what should I write here? What should I write here? Tell me. What is the information given?
It is present at the face centers, so it will be 1 by 2. Yeah. Total 6 spaces.
6 into 1 by 2. Which will be equal to 3. And you will circle this, so and then you will write 4. P1 Z. No, we are not talking about Z. No. ये हम बोल रहे हैं. Just B what? यहाँ पे देखिए जो B हम पढ़ा रहे हैं. Okay. So face centers is what? Q, and then you will write Q as 3, and then you can write it as PQ3. And because you know that we don't write Na1 and Cl1, right? So 1 is not written in the formula. So the formula will be PQ3. Is that right? Yes or no? Please tell me. Any doubt till here?
No, sir.
Hamza, what about you? Clear, na, Hamza? Yes, Hamza?
Yes, sir.
So you just write the face center, the number of atoms, and then the contribution. And whatever you are getting, you'll circle it. Now you have to please remember that you will simplify them into the nearest whole number ratio. Okay, simplest whole number ratio. Always the formula is written as simplest whole number ratio. Okay, so I will give you some examples for that also where you have to simplify. First, write this question. Achha, ek kaam kijiye, don't write this. You have written the question, yes or no? You wrote the question?
Yes, sir.
हाँ चलिए ठीक है ना. Answers आप लोग कीजिएगा खुद से घर पे. ठीक है. I have explained you guys. है ना? Then you can practice also the same things. Then next question. Write next question. Write the next question. The solid is formed by 3 elements. X, Y, and Z. Atoms of X are present in the corner of cube, corners of cube. Atoms of Y are present in 4 of the face centers. Atoms of Z are present in remaining, let us rewrite it like this, 3 of the face centers, and atoms of Z are present in the remaining face centers. You wrote the question, all of you?
Yes, sir.
Okay, now let's look at the solution. So in solution, x is present at corner. This will give me 8 into 1 by 8, which will be equal to 1. Y is that 3 of face centers, right?
Yeah.
Right. So 3 face centers means we have
3
3 into the
1 by
contribution. 3 into 1 by 2 will be equal to 3 by 2, right?
3 by
Correct.
Yes.
Then you have Z. These are present in 3 of the face centers, right? The remaining will be how much? 3 only.
Remaining
We have 6 faces. 6 faces. So again, 3 into 1 by 2, which will be equal to 3 by 2. So now you have got x is 1, y is 3 by 2, and z, sorry about that, y is 3 by 2, and z is also 3 by 2. But we never write the formula like this. Yes or no? Correct? Arihayana.
Yes, sir.
So what we will do, we'll multiply 2 on all of these. Okay, so if I multiply, because this is, I hope you know that it is kind of a ratio, right? When I say NaCl, what does that mean? I mean that there is one chloride atom for each sodium atom, correct? So 1 is to 1 is the ratio here. MgCl2, there are 2 chlorine atoms for each magnesium. So there is, the ratio is 1 is to 2. So here also it is kind of ratio, we can multiply. Then I have to multiply all a number on all of these elements. So I will multiply 2 in all of them. So I will get x2. If I multiply 2 on y, I will get just 3 because 2 and 2 will be getting cancelled. And if I multiply again 2 in the z, then you will be getting what? Again 3. So it is x2, y3, z3. This is the formula of the compound. So write this question, okay? Because we have to simplify it.
Okay, sir.
Done?
Yes, sir.
Okay, Hamza, what about you? Done? Yes, Hamza?
Sir, 1 minute.
Acha, okay.
Okay, done.
Okay, fine. Now let us write another question. An atom is made up by 2 elements, A and B. Atoms of A occupy the corners of cube, and atoms of B are present at alternate face centers. What is the formula of compound? Try this.
Sir, A is 1, B is 3, 3 by 2, something like that.
कीजिए So what you may have done here is you may have taken A, which is present at the corners, as 8 into 1 by 8, which is equal to 1. And for B, what you must have done is alternate face centers. So you took, like, there are 6 faces, so you took 3.
3
right? Okay. Now let us see if this is correct. Can we take 3, or should there be another number? Let me make a okay. So if you look here, and if I take that, let us put one atom in the ceiling. Okay, I'm putting one atom in the ceiling. Fine. So you can see, I mean, you can assume if you have a fan, if you have a fan in the center, then you can assume that the fan is the place that we have put the atom on. We have put the atom on. Now tell me, all the 4 walls are touching all the 4 walls. These 4 walls are touching the ceiling. Yes or no? All the 4 walls are touching the ceiling. Correct. So these are all adjacent, right? These 2 are adjacent. These 2 are adjacent. All these are adjacent. That means if I put an atom on the ceiling, I cannot put an atom on the 4 walls. Correct.
Yes.
That means the only place left is the floor. Yes or no?
Okay.
So this is the opposite face centers. So alternate face centers. So if you are putting an atom on the right wall, then you have to put atom on the left wall. This will be alternate. If you are putting something on the front, then you'll have to put it on the back. Okay. So these are the alternate faces. It's not that you have to just half it. Understood? Yes or no? Tell me.
Yes.
So this will be how much? 2. This will be 2.
So it will become 1. Okay.
1 by 2, which will be equal to 1, and hence the formula will be AB. Okay. Any problem till here?
No, sir.
No. Okay. Now next type of question is type 2, which is type 2, and in those type of questions you will be talking about, there will be a packing given. Okay, there will be a packing given. So you'll be said that there are atoms of A which are making hexagonal close packing or cubic close packing. So for that also, I'm giving you one question. You can write this question down, and then we will look at what is going to be the formula of compound. Okay. So please write this question down. These questions are also easy. Don't worry about. Similar type of exercise we will be doing in this type of question also. Nothing is different. Write the question. A compound is formed by cation and anion, C and A. The anions form hexagonal close packing. See, they have given. They are not giving you exact position, but they are saying that A is forming hexagonal close packing, and the cations, that means C, it is occupying 75% of the octahedral void. Okay, you have to calculate the formula of compound. These are the only 2 information given, that A is forming HCP, and C, it is in 75%, that means 75 upon 100 of octahedral voids. Okay, so what can we say about A and C? Are you done writing the question? Tell me.
Yes, sir.
Atoms of A are making hexagonal close packing. So when you have A making hexagonal close packing, that means the hexagonal close packing that we made, it is completely made by what? It is completely made by the atoms of A. That means all the atoms present here, everything is what? It is made up of A. And that means you have to take the Z of HCP. Okay. So when you have A at HCP, that means how many atoms are there in HCP? There are 6 atoms in HCP, right? Yes or no? In one unit cell?
Yes, sir.
Now 75% of octahedral void. 75 means what? You can say it is 2 by no, not 2 by, rather it is 3 by 4. Correct? Yes or no?
Okay.
3 by 4, no?
Yes.
So you can say that it is 3 by 4 of means into from bod mass. You understood, right? No, that bod mass is what? Bracket of the division, multiplication, addition, subtraction. O means multiplication. So similarly, we are writing 3 into 4 of octahedral voids. How many octahedral voids are there? 6, right?
Yes.
There are 6. So this will be equal to how much? 2 2s are 2 3s are. So 3 3s are 9 by 2. And here you have A. which is 6, and B is 9. Sorry, we will write the cation first. So C is 9 by 2 and A is 6. Let us multiply by 2 first of all. So you'll get C9 and A6. Now you can divide this thing by 3. So you'll get C3 and there will be A2. Yes or no? C3,
yes,
A2. Okay, C3, A2. Is that correct?
okay,
3 by 4. 75% of the octahedral, right? We have hexaglucose packing that has a 79, 3 by 4. Okay. And so you'll be given this type of questions. Now let us do a few more of this. Write this question. Six, no? So this will be C3A4. Okay, this will be C3A4. They did some mistake in the simplification. Okay, C3A4. Please, okay.
okay. So I want to ask like alternate tetrahedral sides क्या होगा इसके अंदर? ये थोड़ा confused है.
Alternate tetrahedral sides.
Yeah.
Like you try na first. क्या होगा? What do you think? Where are the tetrahedral voids? You have to know that.
Total तो 8 होती हैं. Total 8 है.
Total, yeah. Total there is 8. Correct.
Sir, again 2, I think so.
Why 2?
Face center बोला उसने तो.
नहीं, face center कहाँ बोला? Alternate ये बोला है ना, tetrahedral voids.
Alternate बोला. Sir, can you do this one, please?
I don't even want to try.
Okay. Okay, I will try. Just give me some.
Try to think in terms of na. So what they have said, occupy all the octahedral sides, है ना, and alternate tetrahedral sides, है ना. What is the formula of compound? कीजिए in FCC arrangement.
Okay.
X is making FCC. So this will be 4. Y is making, Y is at octahedral sites, and Y is also at alternate tetrahedral sites.
Sir, I think y is 3 upon 2.
3 upon 2 Y. Y is 3 upon. Octahedral void will be 4, right? And
Okay.
so where do you think, where is the octahedral void is 4? That is for sure, because all for why we have to add both of these things. Tetrahedral voids के लिए बताइए. Tetrahedral voids will be how much?
मैंने तो okay.
So let us see that face centered cubic. Okay.
Okay.
So here we have the face centered cubic, right? Yes or no?
Yes, sir.
So in face centered cubic, you can see that these 3 atoms are there.
Yeah.
And then we have just below it, we have this red atom. Sorry, we have this black atom here. We have tetrahedral void. These are the 3 atoms, and then we have this black atom here, and this is the tetrahedral void that we are making. Similarly,
yes,
we have these 3, and there is one here. Then these 3, and there is one here, and then you have these 3. Okay, and then you have one tetrahedral void. So this is how you are making 4 with one of these, and then you can see that I can make 4 more. Okay, if I add this particular atom, so this 3 atoms, and then this atom will be making 1 void, this atom will be making 1 void. So you have 8 corners. So on each corner, you can say that each corner and the 3 atoms, the 3 walls, we have 1 atom. It is connected to 3 walls, yes or no?
Yes, sir.
Now we have these 3 walls which are making the tetrahedral voids. Okay, 1 atom will be here. So these are the 3 atoms, and 1 atom, let us say, in the top here. So these 3 atoms and this 1 atom, these are making. So we have 8 corners, and all of those 8 corners we are having tetrahedral voids. So in alternate, what will happen in alternate tetrahedral voids? He said, no? What is the question here? Yeah, alternate tetrahedral voids. Then how many will be there? Tell me. If you join those tetrahedral voids, if you join those tetrahedral voids, since you have 8 corners, you can make corners from the tetrahedral void also. Okay. Okay, so what these points are? These points are tetrahedral voids which are made by the corners. Just above, so here you have 1 corner, here you have 1 corner, here you have 1 corner, and here you have 1 corner. So all of these corners are making tetrahedral voids. I have pointed those tetrahedral voids and I have made a cube out of them, right?
Yes.
You can understand, if each corner is making 1 tetrahedral void, so they are just a distance. They're just a distance from the corner, and if you join them, you are going to make a cube similarly, as we have the 8 corners. So if I pick one of these corners,
so there will be only 2. Yeah, only 2.
So I can't pick this one. I can't pick this one. I can't pick this one. Then which one can I pick?
Opposite one.
This one I can pick, right?
Yeah.
After I'm done with this, I can't pick this, and I can't pick this. I can't pick this. Then what else can I pick now?
Now side one, side.
This one, I can pick this one, right? And what else can I pick? I can pick this one also.
Opposite side.
Right, this one. So how many do we have?
4.
4. Okay. So we have x4 and y is how much? 8. So this will be equal to x, y, 2. Correct? Yes, sir. Got it?
Yes, I got it.
This is how you are going to look at the tetrahedral voids. Okay. So let me just trying to show you one photo where you can see the tetrahedral voids more easily. So see, these are the phase center atoms, as you can see. One, second one we have here, and then we have one phase center atom here. Okay, and then we have the corner atom, which is this corner atom. And as you can see, this is making one tetrahedral. Okay, so the tetrahedral void which will be present, it will be somewhere here. Okay, and then you can make there will be some atom here, and similarly there will be some atom here. You can see you will be having some atom here, and then if you join them all, you can make a you can again make some kind of cube, which will be smaller in size, but they will be joining the tetrahedral voids. 8 corners, 8 tetrahedral voids, and if you just take some distance away from the corner and make a center here, the center here, then one center here, and similarly on the from those back corners also you'll be making one cube. Okay. So this is about, so this is the type of question where you'll be getting face centered or hexagonal close packing, and you will be also given the cations that they are in, and they will be in voids. So atoms forming the atoms, they will be forming one of the packings, and the other atoms they will be in the voids. So let us do one more question, and then we can look at some different types, some different concept. Okay, you write this question.
Sir, again, this is FCC.
Yeah, correct. FCC, because we have cubic close packing, and the units for cell for cubic close packing is FCC. Correct.
Sir, it is it's coming like 4/3, 4/3 in both P and Q. But if we do ratio, it will coming 1. So P1, Q1.
So it is saying metallic oxides, oxide ions are arranged in
Cubic close packing.
cubic close packing. Okay. So there are 3. Can you see? We have oxygen ion. Okay, we have oxide ions. 1/6 of the tetrahedral voids are occupied by cations P, and 1/3 of the octahedral voids are by cations Q.
Yes.
So we have oxide ions, we have P, and we have Q also. Okay, so please remember that we have oxide ions. Okay, oxide ions are making CCP. That means it is 4. Okay.
Yes.
Then you have P atoms. P atom is 1/3 of octahedral void, which will be equal to 4/3. 1/3 into 4, right?
4/3.
4/3. And then Q, 1/3 of.
Again 4/3.
Oh, wait a second. 1/6. Okay, this is something else. Sorry. P at 1/6 of the tetrahedral voids are occupied by cations P. 1/6 of tetrahedral void, right? Sorry. So this will be 1/6 into 8, which will be equal to 4/3. And Q is 1/3 of octahedral voids. So 1/3 of OV, which will be equal to 1/3 into octahedral void is equal to 4. So this will be also 4/3. But you have here oxygen atoms also. Okay, so you have P 4/3. Q is also 4/3. and we have oxygen atoms, which are 4. So I will multiply 4, sorry, I will multiply 3 here, and I will be getting P, which is equal to 4, Q is equal to 4, and O will be equal to 12. Now I can divide by 4, right? Yes or no? I
Yes,
can
sir.
divide by 4, so I will get, okay, this is oxygen, not Q. My bad. This is oxygen. Okay. So P will be equal to 1, and Q will be also
Q also
equal to
1
1, and
3.
oxygen 3. So PQO 3. Okay.
Okay.
So please write this down. PQO3. PQO3. Done.
Yes, sir.
Next is, so this is the two type of question that you will be getting in formula. Okay, I hope you can do that now. Okay, I will give some in assignment also. Now let us write another topic, that is density of unit cell. Density of unit cell. Okay, in density of unit cell, we have, so what is the formula for density? Density is equal to, generally speaking,
Basically, it is rho equal
mass
to
by,
mass upon volume.
sorry,
Volume.
mass upon volume, right?
Yes.
So when I'm talking about density of unit cell, then it will be mass of unit cell divided by the volume of unit cell. Yes or no?
Yes, sir.
Okay.
Sir,
So now let us look at
so डेंसिटी जो होती है, अगर हम H2O की लें तो अगर हम CGS ले, CGS में तो ग्राम अपॉन CC होता है. ये CC क्या होता है?
cubic centimeter.
Cubic centimeter. Thank you, sir.
Centimeter cube. Okay.
Okay.
So in this first we will see what is the mass of unit cell can be. Okay. Number one is we will see what is the mass of unit cell. Now, like specifically speaking about unit cell, so unit cell is nothing. These are just lines, you know. So as you don't have any equilibrium is not there, right? You don't have any equilibrium, right? Sorry, equilibrium border. Sorry, equator. There is no equator. Why? Because equator is an imaginary line, correct? Yes or no?
Yes.
Similarly, unit cell is, I mean, there is no lines present inside a particular atom. We make those lines and we make the unit cell. But the mass of unit cell, it will be due to the atoms, due to the atoms in unit cell. Yes or no?
Yes.
Correct. Now, due to the atoms, that means you can see the mass of unit cell. It will be equal to Z, that means the number of atoms, into the mass of one atom. Correct?
Yes.
Now, so Z we know. What is the mass of one atom? Mass of one atom will be, we only know from periodic table, that is the molar mass. So molar mass is the mass of how many atoms? Tell me. 1 mole. Correct? Molar
Yes.
mass is the mass of 1 mole. So if I divide the molar mass by the Avogadro's number, that is 6.022 into 10 power 23, then I will get the mass of one atom, right? You have a mass of 6.022 into 10 to the power 23 is
23.
molar mass, correct? 1 mole. So if I need mass of one atom, then I will have to divide this number by molar mass, correct? Yes or no? M by Na.
Yes.
Then I will get mass of one atom. So we have mass of unit cell, which is equal to Z into M upon Na. Is that right? Yes or no?
Yes.
Okay. Second is the volume. Volume of unit cell. If you look at the volume of unit cell, wait a second. Volume of unit cell, okay. We have seen two types of unit cell in 3D. One is cubic, one is hexagonal. Is that right? Yes or no?
Yes, sir.
So for cubic, the volume will be A cube, right?
Yeah.
For hexagonal, you have to use this mind trick, which is known as volume is equal to always what? Area of base into height. How? If you remember, what is the volume of a cylinder? Tell me. This is pi r square h, correct?
Yeah.
The pi r square is what? The area of base, and h is the height. Yes or no? So if you remember hexagonal close packing in 2D, we calculated the area of the base, which was equal to 6 into root 3 by 4 a square. And height of hexagonal close packing, hexagonal unit cell will be c. Okay, but the important thing is that you don't have to remember this. This will not be asked. Okay, after the exam में नहीं है वैसे तो, but even in the entrance and all, they will not ask you directly. Okay, they will not ask you to calculate the density of hexagonal unit cell. But I think they have asked once. I think they have asked this: what is the area of hexagonal unit cell? Sorry, what is the volume of hexagonal unit cell? So you may remember and you may keep this in your notebook. Okay, you may keep this in your notebook. The volume of a unit cell is what? Always AQ. Volume of unit cell is AQ. Now we have the densities formula. So you can write density is equal to the mass of unit cell, which is equal to Z into M upon NA. And what is the volume here? Volume is AQ. So the density of a unit cell will be equal to Z into M upon A cube into NA. Z into M upon A cube into NA. Okay. Now in this, you have to remember a few more things. That M, this will be in, so will be always in grams per mole. Okay. And A cube will be always in centimeters. Now, A will always be in centimeters. A cube will be in centimeters. Let me write it like this. A in centimeter. Okay, A is equal to centimeter. And if I talk about the density, then density should always be in grams per centimeter cube. Okay, so please write this down. I think I need to scroll a bit above, right? चलिए यहाँ से लिखिए.
सर अगर ये पिकोमीटर में होगा तो हम इसमें 10⁻³ ऐसे कुछ
12. Yeah, you have to convert to meters.
12.
And then to centimeters, it will be 10⁻⁻10.
Okay.
तो ज़ैद आपके स्कूल में सॉलिड स्टेट चल रहा था शायद ना?
Yes sir.
आज आप गए थे स्कूल?
No sir. Today is follow.
अब नेक्स्ट टाइम जाइए. अच्छा, छुट्टी तो नहीं मिल गई कहीं आप लोगों को? छुट्टी कब से है स्कूल में?
छुट्टी
ईद की
छुट्टी अभी कंफर्म नहीं है, लेकिन हमें तो एक दिन पहले मिलती है आई थिंक, या फिर सम डेज इट इज लाइक 5 days बिफोर.
अच्छा, 5 दिन की छुट्टी रहती है ईद में? अच्छा.
ओके सर.
Hamza, what about you?
Yes, sir.
Okay, now write volume of unit cell.
Okay sir, finished.
Done?
Yes.
Okay, what about you, Hamza? लिख लिया आपने? Yes, Hamza, done? नहीं.
No.
अच्छा, लिखिए आराम से लिखिए, फिर बताइए हो जाए तो.
Okay, done.
Done. Okay. Write this question. basic formula based question you have. An element having BCC geometry has atomic mass of 50 U. So what you will do, you will convert this to 50 grams per mole. Okay, you don't need the mass of an atom, you need the molar mass, so 50 grams per mole. Calculate the density of unit cell if the edge length is 290 picometers. So in solution, you can see that since density is equal to Z into M upon A cube into Na, okay, they have given us, so from BCC, what you can calculate? The Z, right? So what will be the Z for BCC? Tell me. What will be the Z for BCC? What will be the Z for BCC?
So it's 2.
2, correct. Then you have also been given the molar mass. You have also been given the edge length A, right? So you can A cube it, and then you have been given the so Avogadro's constant is a constant, you don't need it, right? In the question. So first thing that I would suggest is always calculate the volume. Okay, so volume will be equal to 290 picometer cube. So this will be 290 into 1 picometer will be equal to 10 to the power minus 10 centimeter whole cube. So this will be 290 cube into 10 to the power minus 30 centimeter cube. Okay, so first of all, calculate this one, and after that you will put it in this formula for density, and then you will calculate it. Okay,
Okay.
please write this question down, and then you can do it. Right now you just have the calculation left, correct?
Okay.
Yeah, so please write it down, let me know when you're done, then I will leave you guys, and we'll meet tomorrow. I will go have my iftar pre-maghrib. Okay, let me know when you're done writing the question.
Done.
Okay.